We'll dive back into transportation. So remember we finished up talking about biofuels, which is kind of like a fuel way of trying to decarbonize our system. But we talked about whether that's actually decarbonizing, right? Really depends on what you're talking about and where you're getting your biofuel from. Today, we're going to start with talking about another way that we can try to address these externalities with our transportation system, which is thinking about efficiency and electrification. And I put those in the same category because as we've talked about, one of the great things about electrification is it is an efficiency thing too. It's often 3-4 times more efficient way of getting the service we want than its fossil fuel counterpart. So we see that in buildings, we see that in transportation. So it's kind of exciting on all those measures. You guys have probably gotten the sense that I like the Simpsons. So this is a really old Simpsons. If anybody's ever been to Disney World, they have Tomorrowland. This was like a play on Tomorrowland where it was the electric car of the future, only it was sponsored by the oil and gas industry. It's a really funny clip. So if you want to go check it out, I'm sure you can find it. So this electric car is very sad. It's a very sad electric car. Electric future looked very sad in this ride. All right, so let's talk about the different systems and different places. And we're going to start with big picture a little bit because, as you'll see, this is relevant when we're talking about efficiency and air pollution. So what I'm showing you here is gasoline consumption by region or country and diesel consumption by region or country. And you'll see something very different in terms of the US versus Europe on what fuel kind of dominates our systems, right? Gasoline really dominates in the US, diesel dominates in Europe. There's 2 reasons for this. Anybody have a guess on why? Why is that? I mean, we're just driving around. Why would they use diesel and we use gasoline? Yeah. Different emission standards is one of them. So we talked about how California has really led the way on air quality standards in the United States. And the diesel cars don't meet our air quality standards. We could have a whole class on Dieselgate and Volkswagen and the whole, trying to get around these standards. But the bottom line is that it's harder to make a diesel engine meet our air quality standards. You can, but when you do that, you tend to lose the fuel economy benefit because it takes more energy to do that. So that's one of the big reasons why this is very different, is our air quality standards are stricter than Europe. What is it about gas prices? What about prices? Anybody driven around Europe? They're way more expensive. It's way more expensive, pure liter, gallon, however you want to think about it. Diesel engines are more efficient than gasoline engines, but tend to be more costly up front. So if you have a higher fuel price, it kind of makes it worth it, both to have a smaller car, more efficient, but also to expend that extra capital in the upfront part to have a more fuel efficient vehicle because your fuel costs are higher than they are in the US. And we'll look at fuel costs. So those are kind of these are the aspects that really impact our transportation system. We're going to talk about the efficiency aspect and then we'll talk about electrification. So this is giving some of the countries looking at the cost of the gasoline or the fuel itself and how much tax is on it. So taxes, right, are one way that we can, get money to pay for our transportation system, but also a way of incorporating externalities, right? If you think about if we wanted a carbon tax or something, that's what we're trying to do, is make it more expensive. At the top of this chart is a lot of the European countries, highly taxed on their fuels. It's more expensive per gallon. Here's the United States. Our gas tax was last changed in 1996 and hasn't really changed since then. It is politically not something people want to talk about or address. Politically not favored. So we have a pretty low gas tax. So you can think about how that doesn't encourage efficiency, right, when we have relatively low fuel costs. I put this little question in here. It's well, are taxes really a good idea? And having high taxes on our fuels? Because it's generally considered pretty regressive in the sense that in terms of lower income households, they already have a high portion of their budget that goes to energy, right? And they tend to have to drive farther for economic opportunity. And so there are definitely studies you can show that just having a higher gas tax can be pretty regressive in terms of having a higher impact on low-income families. Okay, so that's what the landscape looks like globally. It also differs regionally. This is just to give you a sense. We always are talking about California has some of the highest costs in the country for a number of reasons, including we talked about California has boutique fuels, right? Because we have higher air quality standards for us. But we also have pretty high taxes on it. So you can see both on gasoline and diesel, there's California up at the top, followed by Illinois and Pennsylvania, just kind of leading the way on having high taxes on our fuels. Yeah.
If everyone adopted California fuel standards, would the price of fuel come down? Or are those costs due to refinement?
Yeah, I mean, you would have extra cost of refining because it's an energy input that really leads to that extra cost. So I'm not sure scaling it would do a lot to change that. So there's where we are in taxes. And of course, there's other things that come into prices in terms of what we're paying at the pump. I don't want to spend a lot of time on this, but you guys can check this out later. Okay, so that's where we are in prices. But we can do a lot better in terms of efficiency. We talk a lot about efficiency in this class, right? So this was a nice book done by Stefan Heck and others called Resource Revolution that was looking at a lot of different transportation efficiency, but this is the one for vehicles themselves. And again, you know, only 1% of your fuel is moving you around. You have a lot of engine losses, right? We're using heat to do work. That's just generally lossy, even when we do it really well. And then you have, of course, frictional losses, aerodynamics, inertia, et cetera, that make just using a heat engine a pretty lossy, inefficient way of moving us around. So if you remember what we did, we talked about this on Wednesday in order to try to improve the efficiency of our vehicles after the Arab oil embargo. We implemented something called the CAFE standard, Corporate Average Fuel Economy, and we'll talk about what that means. So the fuel economy standard went in place in the 70s. You can see we had this dramatic improvement in our fuel economy. It kind of tapered off during the 80s and 90s, and then really in the early 2000s when we started to get serious about it again and have increased the standards, you can see the fuel economy of the vehicle fleet on the road has gotten better driven by this policy. So what is it? What does corporate average fuel economy mean? It's really, I'll just put this all up here. It means that it's the average for what mix of vehicles each automaker sells. That sets their standard. And so your standard is based on the types of cars you're selling. So in the past, it was like just cars and trucks that had different standards. Now it's based on the wheelbase of your car. So how far apart your wheels are depends. You have a different fuel economy standard for the different cars. And so you get a standard based on that mix that you sell. That's your standard that you have to meet. Why do we change the fuel economy like standard for different size cars? It's because the automakers complain that if you just had one standard, they'd have to only sell small cars, which aren't what consumers want. They wouldn't be as safe, et cetera, et cetera, et cetera. And so it's kind of like that's the compromise. The fuel economy standard changes. It's less strict on bigger cars than it is on small cars. Okay? So they have some mix of fuel economy that they have to meet. We do have, it's both a fuel economy standard and a carbon dioxide emissions standard. And it's a cap and trade system. They can trade credits with each other. It's been a cap and trade system for a long time in terms of being able to trade credits with each other. But it really wasn't until Tesla came on the scene that a lot of trading happened. The automakers aren't necessarily known for working well with each other. They're competitors, not collaborators. But Tesla doesn't need their credits, so they just want to sell them all. And so it really kind of, I guess, kickstarted actually having the credits move around. Okay, so this is what we've had in place for a long time. We have to see what's going to happen. So this policy is still in place, but the current administration basically removed penalties for not meeting it. So if you think about the incentives of this program now, there's no stick for not meeting your standards as an automaker. This is what it looks like. So one of the interesting things about the trading that goes on in this system is it's not a transparent market. So they have to report what credits they have and what credits they've sold and what credits they've bought, but they don't have to report who from whom, and they don't have to report for what price. So we don't know. They don't have to disclose that. This is what it looks like. So these are the standards in the little boxes, and then you can see the actual performance. Another thing about these credits is they can apply like 3 years back or 2 years forward. You can kind of bank them. So if you don't meet it a certain year, you can use credits to meet it in the next year, things like that. But again, you know, when you have an all-electric company like Tesla, they just get credits that they can just get rid of and they don't need. All right, so like I said, it's not transparent, but we do get to know who's selling. Tesla, Honda, Toyota typically are sellers, and who's buying. Stellantis, GM, Mercedes, big buyers, right? So you get a sense of whether they're meeting their fuel economy standards or not. So when this went into place, of course, there was a lot of concern about you wouldn't have fast cars, you wouldn't be able to do horsepower and efficiency. Like I said, you'd only have small cars, things like that. Hasn't turned out to be the case. So a few things I'm going to show you here. This is basically the change since the standard went into place. And so at first, we did lose some size and horsepower in our vehicles, but you can see that's come right back up in terms of weight and horsepower. And of course, you already seen what the fuel economy looks like. When we had that kind of stagnation in the 80s and 90s, not just stagnation, but actually our fuel economy went down, was because we had a lot of switch. So if you think about the standard stayed the same for cars and trucks at the time, but we switched a lot more from cars to trucks. Trucks and SUVs became really popular in the 80s and 90s. And so we saw overall fuel economy decline because they had a less strict standard for cars and SUVs. You can see that they are a big part of the market now in terms of cars and SUVs, but our fuel economy, as the standards have gone back in place, has continued to improve. So it just really points out that importance of the standards. So best data that I can find in terms of where the US lines up with other countries is shown here in terms of fuel economy standards. Other countries do it different ways. I don't think anybody else does it as this like just an average of the sales, at least that I can find. China tends to have like, this is the minimum efficiency you have to meet. So that's a pretty common and simple way to do standards, is just have an efficiency you have to meet and just continue to ratchet that down. But you can kind of see there's a lot of countries that have some sort of efficiency standard that their vehicles have to meet. All right, so how do we make them more efficient? Amory Levins, this is from Amory Levins' study, would say, well, the first thing you should do is make the car lighter. That's easy. That's something BMW did with their i3, with having a full carbon fiber chassis. Carbon fiber has been looked at for other things. It's a very resilient, pretty safe, lightweight material, but manufacturing can be challenging, recycling can be challenging, so it faces other challenges. But lightweighting is certainly one way we can make things more efficient. And then, of course, electrification, right? So this is our former teaching colleague, Carl Knapp, who used to teach this class. He unfortunately passed away from ALS a few years ago. But literally, this was a little Dutch electric vehicle that he would literally drive up to class because he could fit through between the pylons on campus and drive it to class. We partner with Actera, which is a local nonprofit that is trying to do electric vehicle education. And so the Go EV Carl Knapp program is all about education, especially for low-income communities. What are the benefits you can have? What tax breaks can you get? The things that are really just about education on electrification of vehicles. So great organization. If you want to get some volunteer hours or do something, you can check out what they're doing. Okay, let's talk about what electrification means, because there's kind of different levels of electrification, right? So you can do 100% electrification. That's our EVs, electric vehicles. There's a lot of advantages for doing this. One is you only have one system. You have batteries and an electric motor. It's really simple. One of the things I love is not having oil changes and that kind of stuff. You don't have that. You have white washer fluid and tires that you have to maintain. The rest of it's really simple. You have regenerative braking. So with an electric motor, remember an electric motor is also a generator. So instead of slowing yourself down with brake pads, which are just friction and creating heat, you actually are creating electricity using that electric motor as a generator to generate electricity, put it back into your battery and slow you down. You can do this on hybrids and other things, anything with a battery and some sort of motor, right? So that's a huge efficiency gain because you're creating that, you're recapturing that energy when you slow down, right? So electric vehicles, like I said, this is kind of the simple one. I would say, the barriers, and we'll talk more about this, are things like behavior change. For sure, you kind of have to have a different planning when you're using your electric vehicle. You can do hybrid electric vehicles. This requires no behavior change, but you do have two systems. This would be like your Prius, right? Also has regenerative braking, has a small battery, has a smaller engine. One of the advantages of it as a hybrid electric vehicle versus a gasoline vehicle is these engines have a point where they are most optimal in terms of where they operate. And when you have a hybrid electric vehicle, the battery can really do the offsetting, and that the gasoline engine can kind of operate at its optimal, most efficient place. So you get that additional advantage with a hybrid electric vehicle, and that's one of the reasons you really see the improvement in fuel economy over the gasoline counterparts. So a huge efficiency there. Of course, you can make a plug-in hybrid that just has a little bit bigger battery and you can plug it in. Studies have been, we've had these around for a while. Things like the Volt. As a hybrid electric vehicle, you have a short amount of range that's all electric, but you still have the gasoline infrastructure. The way people use this tends to not be any different than a hybrid. We don't see people actually doing a lot of plugging in of their plug-in hybrid electric vehicles. So it tends, based on the data, it tends to operate in a very similar manner to a hybrid. And then fuel cell vehicles, right? This is just another form of electrification where now you're using hydrogen on board to create your electricity to run your electric car, right? So a fuel cell vehicle would have both the battery and a hydrogen tank with the fuel cell to generate electricity to run the electric motor to drive your car. We've talked about how all those energy conversions can really make it less efficient from a system standpoint, because especially if you're making green hydrogen from electricity and then you're making it back into electricity to drive your car, that's a lot of conversions where you have a lot of losses. But it is essentially an electric car. You guys have gotten a sense I'm pretty excited about electrification, and I just kind of put together my reasons I'm excited, and then the reasons it's challenging will come next. So these are just my reasons that it's exciting, having been an electric car owner for 10 years and in a variety of different living situations, which we'll talk about. There is definitely some different planning you have to go into. I don't miss going to gas stations, and I don't miss oil changes. The convenience of fill up really depends on if you can fill up at home, which we'll talk about. So that can be an advantage or a disadvantage. But really that top one is one of the reasons I'm really excited about it. Having spent a lot of time in working on air pollution and the impacts on human health, if we can electrify transportation, we're getting those sources of air pollution out of our communities where it really impacts people. We're getting it off our highways where it really impacts people. So that gets me really excited about electrification. There are a lot of challenges. As we've gotten more variety of electric vehicles, they're more affordable. I've definitely, I have 2 used electric vehicles now, so that's a lot more affordable than new electric vehicles. But there's a lot of challenges, and I would say, as we've talked about globally, you have to have an electricity system that can support it. So there is that investment. You have to have affordable, reliable electricity as a fuel system in order to support this kind of transformation, right? So that's a big challenge. There was a study done by the IEA that kind of listed the biggest challenges for EV adoption, and of course, charging infrastructure and lack of appropriate EV type, followed by capital costs. These are no surprise to any of you. Those are the biggest barriers. So I expect these will all get better. We're seeing them all get better, but those are definitely challenges. Yeah, I've really enjoyed it. So I've had it for 10 years, and I often get asked, I'm like, oh my God, is your battery still lasting? So my original range, I think at that time was 275. I think it's down to about 260 something, 264 maybe. That's the range loss I've had with many, many trips to LA and Tahoe. So that's what happens. Your battery does lose range over time. And then my hope is that when it gets so low that it's not useful to me anymore, because I do know some people that have Leafs that only have like 15 or 20 miles of range on them left. Then you give it to Revo Materials, right? And they either use it as grid storage or they recycle it, right? So we can keep it in the system and keep it going. All right, you guys have seen this already before, but I just wanted to remind you, these are all the reasons we've talked about and why we might want to electrify systems. And so transportation is one of those. What does the efficiency gain look like when we're talking about electrification of transportation? So on the top, I'm showing you a gas car, right? You're putting in 100% there. This one, you're getting 20% driving motion, about 1% moving the person, the rest is moving the car around. Here you are in your electric car. You get not only the electricity, but you get regenerative braking. So way more is going to actually moving the car around and even more for the person around. So they're 3 to 4 times more efficient. And that's the first magical thing about it, right? Because then the next question I get, is, what if it's supplied by fossil fuels, right? What does it look like then? Or is it really better? And because of that efficiency, the answer is yes, it's really better. And then of course, as we've talked about, you can green your fuel over time, right? That's the advantage. So this is a DOE website. So I encourage you, if you have a state that you want to go check out, you can go check out a state here. This is showing the national average and then California. What it's showing you here is pounds of CO2 equivalent, basically emissions per vehicle. So these are annual emissions per vehicle. So on the national grid, here's what your electric car looks like compared to a gasoline car. California, looks even better because of the mix of our systems. But of course, I wanted to look at some that were much more fossil fuel dominated. So here we've got West Virginia, which is very coal dominated electricity mix. You can see your electric vehicle, still a lot better than your gasoline vehicle, but closer to a hybrid, right? So again, the advantage is though that car is going to be on the road for, I'm hoping to drive mine for 20 years. We see averages of 17 years-ish. You can green that over time, right? Unlike the hybrid. And then here's Hawaii, which is very oil dominated still. Hawaii has a lot of renewable energy standards, but there's still very oil-dominated electricity mix right now. And you can see, again, it's still better, but not as much as other systems. Range anxiety. So often people are like, average, we only drive 40 miles. So what the heck's the problem? But I would say nobody is investing the capital expenditure for a car for their average use. They want it to meet all of their needs. It's like, I want it to meet my long drives and my other trips and things like that. But we've seen an improvement for sure over time in terms of the average range. This is in kilometers, so I tried to give you the miles for us US people, the equivalent there. But you can see that range has been improving with improvement in batteries. And so this is one of the things that has gotten better with the mix of EVs that we have available. Charging infrastructure is a big one. So first thing I want you to understand is what are the different charging options that people talk about? Level 1, level 2, DC fast, what does that mean? Okay, so this is kind of your reference to what that looks like. Level 1 would be just plugging it into the wall like you would your phone or your computer or something. You can see that if you do that, you're very limited in terms of the voltage and amperage you can get. You're going to get 3 to 5 miles of range per hour. I've done this. I had an apartment that didn't really have any way of charging my car except with the extension cord out my window down to my car. And so I would get about 3 to 5 miles of range an hour. Luckily, I was using the Caltrain to get to work, so I could let it charge for days to charge back up. So that's just plugging it into the wall. Level 2, this is a level that is available pretty much any single family home in the United States. Because we have 2 systems in most houses, That was originally for electric dryers. Electric dryers needed a higher voltage, and so you had kind of like the 120 volts and you had the 240 volt system in your house. And so like what I have now is I just have a plug on the 240 volt system that looks just like a dryer plug. And you can literally just plug your car into that instead of putting in electric clothes dryer. Then you're getting more like, I get almost 24 miles of range per hour. Much, much faster. Doesn't require any fancy things. You don't actually have to buy the fancy car charger thing from Tesla or something. You can literally just plug it into the 240 volt like you would your electric dryer. Okay, and then often for our public charging stations, some of them will be level 2. That'll be slower, but you can do that. We also have DC fast chargers, a lot higher voltage. You can see 80% charge in 20 to 30 minutes. It's much faster. The fastest point of charging is kind of between 20 and 80% charge. Once it gets close to full, the charging slows down. If you think about it, it's just getting full, and so then it has to kind of be more careful about how it's shoving those electrons in. So this is kind of what you would see if you're at a lot of public stations. Tesla superchargers, these are even getting more than this. So 200 miles in 15 minutes is, if you're between the 20 and 80%, pretty easy. So now when if I want to drive to see my brother in Los Angeles, I just stop twice for 20 minutes because that's fast. I don't go all the way to 100. It would take 40 minutes. I just do 2 stops for 20 minutes and I can get to LA. So that's how you can kind of optimize that. These chargers are growing worldwide. No surprise, led by China, right? Because they have a lot of electric vehicles. Their electric vehicle fleet is growing by leaps and bounds. And they're really investing in public charging points. And you can kind of see the different types of charging points. So you do have these, would be like the level 2 when it says slow versus fast or ultra fast in terms of the charging network. I mentioned Dieselgate and VW's diesel scandal. One of the things they had to do after that was to start a nonprofit called Electrify America, which is investing money that they put aside into an electric vehicle charging network, public charging network. So that was kind of one of their punishments from that scandal. Okay, so this is what the charging network looks like in the United States. So Tesla definitely has the most extensive fast charging network, but you can see ChargePoint has a pretty extensive level 2, and some of them are fast chargers and things like that. So we're seeing growth in this area, and this is kind of what it looks like now. So you can get around most of the country with your electric car with public charging these days. All right, so that efficiency gain, what does it look like in terms of cost, in terms of your mileage on your vehicle? So this is just showing you this is from the Bureau of Labor Statistics and EIA, looking at, how much does it cost for your electricity and your gasoline. So this is, per mile or per 100 miles for this. Two things to note, right, is electricity is a lot cheaper than gasoline per mile, but also that electricity tends to be much more stable and less volatile than you see for gasoline prices. Gasoline prices tend to go up and down a lot more. Of course, we can't forget the challenges of electrification, and one of those are the critical minerals in our batteries, right? So this is just kind of a visualization of showing the geographic distribution of some of those minerals, lithium, cobalt, manganese, and nickel, in terms of where they are and who owns that kind of distribution network. So with global trade, with some of the challenges with tariffs and I guess the ongoing trade wars with China, a lot of this can be more, just more risky, I guess, in order to be able to source these materials. Yeah.
How effective is the recycling of these batteries?
Yeah, so batteries, we can almost recycle at 100%. We can almost make a new battery out of an old battery. It's not quite, but it's pretty close. And I think redwood materials, the last numbers I saw, is about 70% of the batteries are coming through them to do that recycling. So as we're getting to end of life, or some of them, it's not even end of life of the battery, which is why they're just setting up an energy storage thing, is that sometimes it's the end of life of the car, like a car is wrecked or something, but the battery is fine. But the insurance company doesn't want to pay to repair the car. They want to just buy a new car. And so that battery that's just fine goes to redwood materials, and they're doing energy storage first, setting it up to the grid. And then when it gets to really truly at the end of its life, then they'll recycle it. But you can almost fully recover the metals out of it, which is great. And they do this not just with car batteries, they do it with all types of batteries, which you guys saw if you went on the tour. And some of those can be really even more precious in a way because, for example, the battery in your phone has more cobalt in it than the battery in your car per weight. And so that makes that phone battery even more valuable for getting something like cobalt, which can be limited in global supply. So one of the things is where it's located and who owns it. But of course, the other things are, and you hear a lot about this from the DRC, is in terms of the cobalt mining, who's doing it, and what are the conditions. So the human rights standpoint is definitely some of the big challenges for the sourcing of these materials. I think it's funny. This is what they say, but I'm hoping it's going to be 20. I'm at 10 and it's doing just fine. So we'll see. Okay, so you said about recycling. So this is, kind of where battery prices have come down. This is showing the kind of EV battery recycling economics. So the difference between the extraction costs and the margins that they're getting, basically what this is telling you is that it's much more valuable to recycle it than it is to mine it in the first place. And they can make a lot on recycling. And we're just expecting that recycling systems are just going to continue to grow as these batteries get to end of life. So what does it look like? This is our electric vehicle fleet and how it's growing globally. So you can see China, EU, US are kind of the big markets. 2024, more than a quarter of the cars sold were EVs. Most of that, of course, is in China. So we're seeing these numbers continue to grow. The two largest automakers that make EVs are Tesla and BYD. BYD just recently passed Tesla as the largest EV seller. So this is last year. They haven't come out with the latest ones, but they've already kind of announced that BYD has passed Tesla in terms of being the biggest EV seller globally. So if you ride the electrified Marguerite, those are BYD electric cars. Going to policy and policy changes, you can see in terms of share of new cars sold, Norway definitely leads the way on electric vehicles. And that's truly policy driven and truly because the way they put their policies together, it's cheaper to buy an EV than its gasoline counterpart, the way they've done their policies. And so that really has driven that in a pretty cold place where, that does impact your battery range in terms of having it be cold, but they have a lot of electrification. And so this is kind of a summary of some of those policies or the policies we had in the United States. California is in a battle right now with the federal government in terms of being able to ban new gas light-duty vehicles by 2035. So that is an ongoing battle right now. And then, this is just a little bit more about Norway and how they do it. So literally it just makes the EV cheaper. So these all have EV policies or some sort of internal combustion engine. That's what ICE stands for. Ban. So you see those in a lot of different countries. Those are all pretty much around personal vehicles where we've seen the biggest range of options and the most headway. When it comes to heavy duty or long haul trucks, I would say there's still a lot of question on what is going to be the way to decarbonize this. Although if anybody is going to go with Explore Energy House on their tour of the Gigafactory, which I think is coming the first week of spring quarter, they're going to get to go see where they're making the Tesla 18-wheelers because they're just really starting that line. So it's happening, but there's a lot, what is it going to be hydrogen? Is it going to be electric? Is it going to be something else? Buses, we're kind of seeing the same thing, although I think electric buses are kind of making more headway. So this is what it looks like. You can see global bus sales. It's not really an upward trend. It's just kind of like a little bit up and down in terms of electric buses. This is electric truck sales, kind of China leading the way, but these are still very, very small portions of the overall sales. So pretty small piece. And then I don't want to forget about two-wheelers and three-wheelers, because there are some countries that very much depend a lot on two-wheelers and three-wheelers. So from a road transport standpoint, this is the most electrified. But you saw that sometimes this is lead-acid batteries, not lithium-ion batteries. And hopefully you saw the video that I assigned, or the article that I assigned to you about some of the challenges with that recycling system and exposure of people to lead. So more needs to be done there. Kirsten's talked a lot about electrification of school buses. So just a little bit more about that. I think this is a really exciting place to get air pollution away from our kids too. So that's exciting. And then there's all sorts of cool things happening in terms of ski boats or airplanes. But this isn't really a commercial space yet. This boat is extremely expensive, but it looks cool, right? All right, so investment is growing. We're going to continue to see growth and electrification of our system. Okay, so that's it for electrification. The last bit of class, I'm going to spend on some other things that we can reduce externalities and impact our transportation system. So we'll talk about ways to, remember we're doing that Kai identity, ways to reduce vehicle miles traveled, think about embodied energy, and then if we have time at the end, we'll talk about what's happening for the future of transportation, but you guys have some sense of that anyway. So this is inner city passenger rail in the US. This looks very different than if you're in a place like Europe or Japan or someplace else that depends a lot more on rail systems. But you can kind of see we do have rail systems, and this shows some of the advancements or enhancements that are planned for some of our systems. So this is our Caltrain, which I'm so excited that is electrified. I've been taking Caltrain for a long time. Used to take it to campus with my kids because they were in preschool on campus. Had to say all sorts of things I never thought I would have to say, like please don't lick the window, or please don't put that gum in your mouth, or you can't sit on other people's laps. I don't know, it's just crazy. But I really enjoyed, I found community actually on Caltrain because you're taking it at the same time every day. I made some of my best friends actually on Caltrain, especially when you have kids, because they tend to introduce themselves, my kids anyway, to anyone and everyone. So you kind of meet people. So Caltrain, this to me was like, I moved to the Bay Area and I was like, oh my God, I could take a train to work, because I'm from Houston and we don't have trains or buses or public transit really at all. And then of course, people come here from Europe or they come here from the East Coast and they're like, oh my God, all you have is this one train and it barely connects up with BART, and what's the deal with that, right? So a very different perspective on it. So if we talk about urban density and transportation-related consumption, typically if you have higher urban density, you can do better with public transit. So we see someplace like Hong Kong, right? So pretty high urban density, really low transportation-related consumption. You can see my hometown at the other end, up there. Very low urban density is a very large land, very high transportation-related energy consumption. But there is some variability, right, in terms of how much do they focus on things like public transit or walkability or other things that would reduce your transportation consumption. So a very different landscape. So what does it look like in the United States? This is just looking at the commuter pie. So these are people that are going to work. What do they do? In the US, the biggest mode is drive alone. So not with any other passengers. Carpool, you can see, is a fairly big wedge. That work at home being such a big wedge is really different from after COVID. Before COVID, that was a really small wedge. And since COVID, that wedge has really become the second biggest in terms of how people in the United States commute to work. So this is how many vehicles we have per household in the United States. We've already kind of talked about that. We're very vehicle dominated in terms of the US. So a lot of people, a lot of households, 1, 2, 3 or more vehicles in the United States. We drive a lot in terms of in the US. So we drove over 3 trillion miles in 2024. That was a new record. It's around the Earth 132 million times. So it's a lot of driving. This is showing it by different metro areas. In terms of the commute, it's the dominant way that the commuters are getting where they're going. So here's my city, Houston. There's the Bay Area up there. New York, no surprise, much bigger wedge of transit, but still a pretty big wedge. Half the people are driving alone, even in New York. And then we got to look at Stanford. Let's bring it home to where we work and go to school, right? So this is a pretty long data set. So this is over 20 years of Stanford tracking this. And they've done a lot to try to reduce the drive alone to campus. So this sustainable commute wedge would be everything else. It would be carpooling, it'd be Caltrain. They also run a bus sometimes across the bay. So it'd be taking that bus system instead of drive alone. And then you can see this is not just because post pandemic, but they kind of started tracking it a little bit differently too. But they've definitely seen growth in telecommute on campus. There's a lot of different ways that they try to influence this. And it's not just to try to green our transportation. Stanford actually has a deal with the county of Santa Clara that they basically can't increase drivers during commute hours. So they have to take measures to make sure that people aren't driving during commute hours. So they do some of that with carrots of please take Caltrain. We have free Marguerite system, that kind of stuff. They also have tried things where it's we'll pay you $1 not to drive between these hours. You get $1 a day or something. They've tried these other measures because they have this agreement with the county not to increase commute hour or commute driving during the rush hours. Yeah.
Why did Stanford agree to limit the number of drivers during commute hours with Santa Clara County?
Yeah, so it is all part of their kind of land use. So Stanford owns a lot of land, a lot more than just campus, but they're limited in basically the amount of growth they can have, the number of square footage of buildings they can have. And so part of the deal in allowing them to grow was that they wouldn't increase traffic, because the county really is the one that has to invest in the roads and the infrastructure and stuff like that. And so it was kind of a deal you'll let us grow staff and students and stuff. We won't increase traffic by that growth. Okay, so what are we looking at for public transit in the US? We were seeing some modest increase, and then COVID hit. So ridership has been down. It's kind of improved. This is the latest data we have, but it has kind of recovered since COVID. Nobody wanted to be packed together during COVID. So that definitely went into the system. One of the challenges we see with public transit, like I said, you kind of have to have an urban density, and oftentimes it doesn't get you all the way to where you need to go. So this is where studies have shown, Uber and Lyft can be options, can actually be instead of public transit, but they can also support public transit because you can get to a corridor. So for example, some of the studies in San Francisco have shown that people that can afford Uber and Lyft will choose it over the bus, but might take it to the train and take the train. And so it has kind of this dual thing where it can support some public transit, but take away from other public transit options, right? So that first and last mile can be a challenge. These are some of I would say the fun first and last mile solutions that we see in the Bay Area. My husband is a big fan of the one wheel. I think he has every one wheel they've ever sold. But he's also, he broke his collarbone. He's broken both hands. There are safety hazards with these kind of things. He said that's only 2 strikes, and he gets 3 before he gets to stop one wheeling. So, but there are options, and some of them are kind of fun in terms of getting to and from public transit, but that can be a challenge. Final thing I want to say about public transit is that it can really help support equitable transportation or affordable transportation, but it has to be planned right. I mentioned this before earlier when we were talking about it, but a lot of our highway system was really put in place pretty intentionally to divide up neighborhoods, and then investment kind of occurred on one side, and then there was kind of the other side of the tracks, so the other side of the highways. So there was a big study that was done in 2020 by the Congressional Black Caucus Foundation that really looked at this. There's a lot, with an infrastructure like this, it would take a lot to really change that, but there are places that are trying to at least this put a spotlight on where some of those challenges are and how can we improve the accessibility of affordable transportation for economic opportunity. So in the Bay Area, we have something called Plan Bay Area, and it's about a decade old now, but it was the first time where the land use planners got together with the metropolitan planners to actually make one plan. It might be really obvious that if you're thinking about land use and transportation, you should probably talk about that at the same time together. But a lot of times those are different agencies. And one of the challenges the Bay Area has is that public transit is county by county. So it might be easy to get around Santa Clara County or San Mateo County, but then getting between them can be hard because they're county-run systems. So there's all these different public transit systems. So they got the Metropolitan Transit Agency together with the land planners. We have the Senate bill that says we have to reduce vehicle miles traveled in our counties. So this is from the state level saying counties have to have plans for reducing vehicle miles traveled. So one of the big outcomes of this is that we're getting a lot more transit-oriented housing. And so we saw that really go up along the Caltrain corridor. More and more housing that was close to the public transit system in order to increase the convenience of that system. Okay, last thing I'm going to talk about is embodied energy. And if we have time, I'm going to show you a cute little video. Okay. Embodied energy, and I would say this embodied energy, a lot of people think about the cars, but there's a lot more than that in terms of embodied energy in our transportation system. It's the parking lots, it's the highways, it's all of the infrastructure that goes into this very massive system. But when thinking about the embodied energy of the vehicle, I often get asked this, and I get this asked about electric vehicles all the time, in terms of well, doesn't it take a lot of energy to make an electric vehicle? And does it really make sense? And we were just talking earlier about, if I buy a used gasoline vehicle, is that better than buying a new electric vehicle? And so some things to think about in terms of embodied energy, there's been a lot of research on it, so I'm just kind of giving you the range. In terms of the life cycle CO2 emissions, the range is somewhere between 5 and 30% of the life cycle CO2 emissions of your vehicle are from making the vehicle itself, the embodied energy. That varies a ton. It depends on the type of vehicle, where it was made, all of those other things. What are the energy inputs, right? It tends to be that things like advanced vehicles and electric vehicles, more of their life cycle CO2 emissions are in the embodied energy, partly because they're so low for the lifetime, for the consumption part, right? So electric vehicle, you have very little CO2 emissions when you're driving it, so more of its overall CO2 budget is in the embodied energy. It also is true because we have, those minerals and other things that are going into the electric vehicle. So it tends to be higher, but from an overall greenhouse gas emission standpoint, it's much, much lower over the lifetime of that vehicle. Again, even with 30% of your embodied energy, that means 70% of it is when you're driving it around. That's the greenhouse gas emissions part. And so that's where you see it from gasoline cars and stuff like that. We do recycle a lot of our cars. They're lasting longer, at least in places where we don't salt the roads. They're lasting longer. So the average life in the US is 17 years for a car. So that's how long it's on average on the road. But in terms of what we recycle, we talked about this already. A lot of it can be recycled, especially the steel. And of course, in our electric vehicles, the batteries can be recycled. So we do have a pretty robust recycling of our cars, but that carbon fiber, the plastics, those kind of things, We don't have good recycling systems for that. So there are components that we're not really recycling. If we think about the transportation land use, we have a lot of roads. This is the latest data. It's probably grown since then, but we have enough roads at least to like cover Georgia. It's gotten bigger than that. So there's a lot of infrastructure that goes into our transportation system, and we use it at a pretty low capacity factor. So this is from that same book, looking at our transportation system. So two things I'm showing you here is like, okay, we have this embodied energy in the car. How much are we utilizing that car? Not a lot. It spends most of its life parked, right? We're only driving it around some of the time. And my favorite little wedge in there is the 0.8% that's looking for parking. So, you've got 96% it's parked and 1% of the time you're looking for parking it. This has changed some with Uber and Lyft, right? Those cars are getting high utilization. So if you think about the embodied energy that goes into them, they're getting high utilization for those vehicles, but our averages are still pretty low in terms of utilization of our cars. And then we have pretty low utilization of our roads. It might not seem like that when you're in an urban area and stuck in traffic a lot, but on average, we only reach peak throughput about 5% of the time, and it's only covered by, cars 10%. So this is something where automation there's hope that this would help us be more utilization of our roadways with automation, because the idea is that maybe an AI driver could do that more optimally. I think that's remains to be seen, but it's definitely something people are thinking about. All right, so let's talk about Uber and Lyft just for a second. When I started doing my postdoc, I was looking at sustainable transportation. At the time, it was like Zipcar. We hadn't gotten really to Uber and Lyft yet. Like I kind of alluded to, we were talking about public transit. There is kind of two sides, and the research I've seen, it varies a lot on whether Uber and Lyft are increasing energy consumption or decreasing energy consumption. And it kind of depends on what you would have done instead and whether you would have done anything at all, right? So we can think about induced demand is one of the things that's a big question mark. Like maybe I wouldn't have taken that trip if I didn't have something as convenient as Uber and Lyft. That would be an increase in energy consumption, but I would argue also an increase in services, and that's what we want, right? We want people to be able to go somewhere if they need to go. And then whether it's a substitute for public transit or if it's a support for public transit, that's a really big question, and it really depends on location. And of course, we've talked about increased utilization, and maybe it decreases car ownership. If you have Uber and Lyft, you don't own cars. So other factors that are kind of changing the landscape, we see in the United States that young people are waiting longer to get driver's licenses. You've probably seen that yourselves or with your peers. So that is definitely a change, and part of that is because there are other transportation options available. Okay, so where are we going? Well, I think it's a big question. We've kind of talked through it. I don't really want to show you all the different charts, but there's a lot of different ways that we can improve our transportation system, improve services, because that's really what we want. So that's kind of in this landscape. What's going to power it? I'm cheering for electrification for most places, but we'll see if it makes sense in all places. It's really going to depend on batteries. So there's lots of predictions. You guys know that it's like, I don't know that we kind of want to build the future we want rather than look at what's predicted to be the future. This is Bloomberg and kind of their growth on electrification. This is just another study looking at the future. I think what's more interesting is to think about where the systems are going to go in place. So this is just looking at connections for electric vehicles, whether it's going to be at home or public or by truck. One of the possibilities of our electric vehicles, right, would be use it for energy storage, or, so we're charging it during the day on our sunshine and discharging it at night when we need the electricity. But that would mean you'd have to have workplace charging for most people that are driving their electric cars. So that's kind of a shift from where we are now. We've seen these declines in the US in things like gasoline. So there's a lot going on here. These are transportation fuel consumption for OECD and non-OECD. But we've seen a lot of growth in jet fuel. And And so aviation has definitely been a growth area over time in terms of consumption of, and that's expected to continue to grow. All right, so lots there. I have kind of this summary. Thanks, guys. If you want to learn more about this topic or other energy topics, visit our Stanford Understand Energy Learning Hub for free resources, including signing up for our monthly Energy Spotlight. Don't forget to subscribe to our YouTube channel and tap the notification bell to be notified for our newest content.